Biomechanics of human skeletal muscle. ENT 214 Biomechanics. Biomechanics of human skeletal muscle. Mohammed Yusuf Baharuddin. Biomdang Biomed on Melbourne. mysofatanamap.edu.my. Picture from Mr. Biz and Flickr pages. Muscle tissue behavioral properties. Extensibility. Elasticity. Irritability. Ability to develop tension. Extensibility and elasticity. What is extensibility? Ability to stretch or to increase in length. How about elasticity? Ability to return to normal length after stretch. Figure from http://www.flashplayer.com/forum/showthread.php? T = 20485. Elastic behavior parallel elastic component, PEC. Muscle membrane. Supply resistance when muscle is passively stretched. Series elastic component, SEC. Tendons. Act as spring to store elastic energy. Contractile component, CC. Muscle property enabling tension by stimulated muscle fibers. Muscle elastic behavior model. Muscle tissue behavioral properties. Irritability. Ability to respond to a stimulus. Ability to develop tension. The contractile component of muscle function. Structural organization of skeletal muscle. What is a muscle fiber? Because of thread-like shape. Single muscle cell surrounded by a membrane called the sarcolemma and containing specialized cytoplasm called sarcoplasm. Skeletal muscle silverthorn, human physiology. Benjamin Cummings, ISBN 0-321-22687-9, Figure 12-3, p. 392, Skeletal muscle silverthorn, human physiology. Benjamin Cummings, ISBN 0-321-22687-9, Figure 12-1a, p. 390, image taken from http://courses. CM. U Texas. Muscle fibers. Some fibers run the entire length of a muscle, others are shorter. Skeletal muscle fibers grow in both length and diameter from birth through adulthood. Fiber diameter can be increased through resistance training. Muscle fiber, cont'd. Muscle fiber, cont'd. Muscle fiber, cont'd. Myosin and actin. Motor unit, single motor neuron and all fibers and innervates. Consider the functional unit of the neuromuscular system. There are two types. Fast twitch, FT. Slow twitch, ST. Structural organization of skeletal muscle. Fast twitch, FT, fibers both reach peak tension and relax more quickly than slow twitch, ST, fibers. Peak tension is typically greater for FT than for ST fibers. Twitch tension. Time. FT-ST. Skeletal muscle fiber characteristics. Type IA. Type I fast twitch, type IIB. Slow twitch, oxidative fast twitch. Oxidative. Glycolytic. Characteristic. So. FOG. Field goal. Contraction speed. Slow. Fast. Fatigue rate. Intermediate. Diameter. Small. Large. AT paste concentration. Low. High. Mitochondrial concentration. Glycolytic enzyme. Fiber architecture. There are two types of fiber architecture. Parallel fiber arrangement. Fibers are roughly parallel to the longitudinal axis of the muscle. Example, sartorius, rectus abdominis, biceps brachii. Pinnate fiber arrangement. Short fibers attached to one or more tendons within the muscle. Example, tibialis posterior, rectus femoris, deltoid. Fiber architecture, cont'd. Parallel fiber arrangement. Muscle becomes shortened due to fiber shortening. Pinnate fiber arrangement. When muscles shorten, they rotate about their tendon attachment. This will increase the angle of pennation. Greater angle of pennation will induce smaller amount of effective force. Sample problem 1. How much force is exerted by tendon of pinnate muscle when tension in fiber is 100 N, given that the angle of pennation is 60 degree? Ft. Alpha. FF, solution. Ft equals 100 cos 60. Equals 100, 0.5. Equals 50. Ft. Alpha. FF, recruitment of motor units, MU. Slow twitch, ST, fibers are easier to activate than fast twitch, FT, fibers. ST fibers are always recruited first. Increasing speed, force, or duration of movement involves progressive recruitment of MUs with higher and higher activation thresholds. Terms used to describe muscle contractions. Concentric, involving shortening. Eccentric, involving lengthening. Isometric, involving nodes changed. Muscle's role as agonist, acts to cause a movement. Antagonist, acts to slow or stop a movement. Stabilizer, acts to stabilize a body part against some other force. Neutralizer, acts to eliminate an unwanted action produced by an agonist. Two-joint and multi-joint muscles. Active insufficiency, failure to produce force when slack. Passive insufficiency, restriction of joint range of motion when fully stretched. Active insufficiency, failure to produce force when muscles are slack, decreased ability to form a fist with the wrist in flexion. Passive insufficiency, restriction of joint range of motion when muscles are fully stretched, decreased ROM for wrist extension with the fingers extended. Factors affecting muscular force generation. Velocity. Force. Low resistance, high contraction velocity. The force-velocity relationship for muscle tissue, when resistance, force, is negligible, muscle contracts with maximal velocity. Force-velocity relationship. The force-velocity relationship for muscle tissue, as the load increases, concentric contraction velocity slows to zero at isometric maximum. Velocity. Force. Isometric maximum. Length, tension relationship. The length-tension relationship, tension present in a stretched muscle is the sum of the active tension provided by the muscle fibers and the passive tension provided by the tendons and membranes. The length-tension relationship, tension present in a stretched muscle is the sum of the active tension provided by the muscle fibers and the passive tension provided by the tendons and membranes. Tension. Length, percent of resting length. 50 100 150. Active tension. Passive tension. Total tension. Tension. Length, percent of resting length. 50 100 150. Active tension. Passive tension. Total tension. Force, time relationship. What is electromechanical delay, EMD? Myoelectric activity. Force. Stimulus. Electromechanical delay. EMD is the time between arrival of a neural stimulus and tension development by the muscle. Time needed for muscles reached maximum isometric is 0.2 to 1 second after EMD. Muscular strength. The amount of torque a muscle group can generate at a joint. How do we measure muscular strength? Ft. The component of muscle force that produces torque, Ft, at the joint is directed perpendicular to the attached bone. Sample problem 2. How much torque is produced at the elbow by biceps brachii inserting at an angle 60 degree on the radius when tension in the muscle is 400 in alpha? Solution: find Fp, which is perpendicular to bone, calculate torque. Trademark equals Fpxt. Factors affects muscular strength. Tension generating capability of the muscle tissue, which is in turn affected by muscle cross-sectional area. Training state of muscle. Factors affects muscular strength. Moment arms of the muscles crossing the joint, mechanical advantage, in turn affected by distance between muscle attachment to bone and joint center. Angle of the muscle's attachment to bone. Effects or differences: angle B, C. The mechanical advantage of the biceps brachii is maximum when the elbow is at approximately 90 degrees, A, because 100% of muscle force is acting to rotate the radius. As the joint angle increases, B, or decreases, C, from 90 degrees, the mechanical advantage of the muscle is lessened because more and more of the force is pulling the radius toward or away from the elbow rather than contributing to forearm rotation. Muscle power. The product of muscular force and the velocity of muscle shortening. The rate of torque production at a joint. The product of net torque and angular velocity at a joint. Muscular power. Force. Velocity. Power. Power velocity. Force velocity. The general shapes of the force velocity and power velocity curves for skeletal muscle. Muscular endurance. The ability of muscle to exert tension over a period of time. The opposite of muscle fatigability. Effect of muscle temperature, warm-up. The speeds of nerve and muscle functions increase. Effect of muscle temperature, warm-up, cont'd. With warm-up, there is a shift to the right in the force velocity curve, with higher maximum isometric tension and higher maximum velocity of shortening possible at a given load. Normal body temperature. Elevated body temperature. Force. Velocity.